We have first definite integration problem involving modulus function is minus 2 to 1 mod x dx. So what we do is, first we have known that mod x equals to x if x is greater than 0, and if x is less than 0, mod x equals to minus x. So function under the modulus sign, that is x, changes its sign at x equals to 0. So we break our integration at x equals to 0. So minus 2 1 mod x dx can be written as the sum of two definite integration minus 2 to 0 mod x dx plus 0 to 1 mod x dx. So in this interval minus 2 to 0 minus 2 to 0 mod x equals to minus x, since x is negative in this interval, and 0 to 1 in interval 0 to 1 mod x equals to x, since x is positive in this interval. So integration of x is minus x square upon 2 and x square upon 2, 0 to 1. Again we are going to put these values. So this becomes minus 0 square upon 2 minus minus of minus 2 square upon 2 and plus 1 square upon 2 minus 0 square upon 2. So this integration becomes this integration becomes 0 plus 2 square upon 2 plus 1 square upon 2 minus 0. So this is 2 plus 1 upon 2, that is 5 upon 2. So this is the value of integration. So thus we have solved that. We have seen that the value of integration mod x dx equals to 5 upon 2. So this is the answer for the given problem. So again we are going to consider next problem, second problem related to absolute value functions. So we have given second problem. Let's take second example. The second example is minus 2 to 3 mod x minus 1 dx. So we define what is the definition of mod x. Mod x is x if x is greater or equal to 0, and mod x is minus x if x is less than 0. So therefore mod x minus 1 equals to x minus 1 if x minus 1 is greater or equal to 0, that is x is greater or equal to 1, and this is equals to minus x minus 1 if x minus 1 is less than 0, that is x is less than 1. So the function x minus 1 changes its sign at x equal to 1. So therefore we break our limit at x equals to 1. So this integration minus 2 to 3 mod x minus 1 dx can be written as sum of two integration as minus 2 to 1 mod x minus 1 dx and 1 to 3 mod x minus 1 dx. So in interval minus 2 to 1, x minus 1 is negative, so this is can be written as negative of x minus 1 dx plus 1 to 3. In this interval x minus 1 is positive, so this is x minus 1 dx. So we are moving forward. Again this integration minus 2 to 1 minus x dx, and this is 1 to 3 x minus 1 dx. And what is the integration of 1? The integration of 1 is x and x square upon 2 minus 2 to 1 plus x square upon 2 minus x 1 to 3. So again we are going to put the value of limits in integration. So what is the value? 1 minus 1 square upon 2 minus 2 minus 2 square upon 2, and this is integration 3 square upon 2 minus 3 minus 1 square upon 2 minus 1 minus 1, and this integration 1 minus 1 upon 2 minus plus 2 plus 2 plus 9 upon 2 minus 3 minus 1 upon 2 plus 1. So this is 2 plus 2, 6. So solving this, we 3 plus 7 upon 2, and this is equals to 13 upon 2. This is the integration of the given problem. So we are going to next problem. And what is the next problem is? The next problem is third. The third problem is minus 1 to 2. Sorry, our third problem is zero to pi mod of cos x dx. This is our third problem. So first of all, we check that sign changes of cos x. In first quadrant, cos x is positive, so mod cos x equals to cos x. In second quadrant, cos x is negative, that is in interval pi by 2 to pi, cos x is negative. So we keep a negative sign to make it positive, since modulus function always takes its positive values. So this integration can be written as 0 to pi upon 2. We break the limit of integration at x equals to pi by 2, since cos x changes its sign at x equals to pi by 2. So this integration can be written as mod cos x dx plus pi by 2 to pi mod cos x dx. Again, we are 0 to pi by 2 cos in this interval. In the first quadrant, 0 to pi by 2, mod cos x equals to cos x, since cos x is positive. Again, in the second quadrant, pi by 2 to pi, mod cos x is equals to minus cos x, since a cos x is negative in the second quadrant. So this is minus cos x dx. Again, we are going to find out the integration of cos x. The indefinite integration of cos x is sin x, and keep the limit 0 to pi by 2, and minus cos x. The integration of minus cos x is sin x, and keep the limit pi by 2 to pi. And this is sin pi by 2 minus sin 0, and this values minus sin pi minus sin pi by 2. So this integration will be 1 minus 0 minus 0 plus 1 equals to 2. So the value of integration is the value of integration is 0 to pi mod cos x equals dx equals to 2. Again, we have another example. Fourth example is that the fourth example is, what is fourth example? Minus 1 to 1 x mod x dx. Since this integration minus a to a type, so we check fx is even or odd. So fx is x mod of x here. So f minus x equals to minus x mod. So this becomes minus x, and this can be written as this. So minus of mod equals to minus mod 1 equals to 1. So this becomes minus of this, and this is what? This is minus of fx. So f of minus x equals to minus of fx. We are getting minus of fx. So this function fx is an odd function. Fx is an odd function. odd function. So the integration -1 to 1 x mod x dx equals to 0. This is the answer.